Okay, guys, today is our outline for our derivatives quiz. So I'm just going to go through what's on the derivative quiz and just kind of go through a couple questions. I did a summary the other day when we got back, so it's similar to that. Okay, so I'm just going to go and pop that up here, and when the Blackboard opens up, we'll spend about half hour just going through what is the outline for the quiz in derivatives unit, what it will be. Okay, the derivative quiz will be similar to your hand-in, shorter probably. Okay, so we have our derivatives formula sheet that's printed out, and I'll probably add in, the line equation and stuff like that. Okay, so let's just set this up a little bit here. Okay, so this is the day, I don't know, 7, 15, 18, I guess, the outline. Derivatives quiz. Okay, so the first thing is the first sheet on the derivatives quiz is actually a formula sheet that I gave you already in there. So it looks like I'll bring it up and I'll bring it across here. So let me pop it. Oops, I keep doing the wrong side here. Let me just pop it open here for you. So this derivative summary, we did it on day 15, and the derivatives formula sheet looks something like this. Here, so there we go, that we did. Okay, and of course you'll get that at the front. I'm going to add in one here that I forgot to put on there when I made this. Right at the bottom here, I'll add in the line equation and slope equation in case you forget them. But other than that, that's what your derivatives formula sheet will look like. Okay, at the beginning of your derivatives exam. Okay, and then what we're going to do today is we're going to spend our time just going through what is on the quiz. So let's go ahead and do that. So got it right here. So I'm going to pop that open. Okay, so if we're looking at our first question, we have our first question is derivatives, obviously, and it's finding derivatives of basic y equals x expressions like this. Say question one. Okay, and it's worth 10. And it's using find the derivatives using the appropriate rule. And of course, I have in there, express your answers in factored form. Okay, so worth 10. Okay, so what I have in there, I've got a one straight power rule. Okay, I also have another power rule with where you some equation manipulation. Okay, so if you want it, it's got roots in it, so you got to change them into powers and that kind of thing. Okay, that kind of idea. I also have in there as well, I've got a simple product rule. Okay, a product rule. two expressions. Okay, I also have in there as well a product rule with three expressions. What did I put two there for twice? I don't know what the heck that was. Product rule, sorry guys. Two expressions, and I got another product rule with three expressions. Okay, and then the last one in that section is a quotient rule. And just with the two expressions is all we ever did in this. So quotient rule in there as well. Okay, and that's our first question on the exam. So there's 5 derivatives there, 2 power rule ones, 2 product rule ones, and a quotient rule one. All of them you're just going to be using and do the first step and then leave it in factored form. You don't have to rearrange, expand, or reduce, other than real simple reducing. Sorry, guys. So that was the first question on the quiz. Now let's just maybe do a simple example or two. So, for example, okay, let's do okay. Power rule is pretty straight. Power rule comes into play here. So let's do a 3 product rule. That'd be the hardest one we got. Y equals, let's go with, let's make something that's fairly similar but not too hard. Okay, let's say I've got 5 root x times 3x squared minus x cubed, all multiplied by x plus 2x cubed. Okay, so if we're doing the our product rule here, and we consider the A, B, and C, let's say, so it's A prime B, C. Oh, okay, when that happens. Okay, you can give it a try on your own if you want. If you want to pause it and go ahead and try it, I'm going to work it out here right away. So 5, I think it was 5 root x. So I guess we should rearrange it first into fractions. This is 5x to the power of 1/2, 3x squared minus x cubed, x plus 2x. Okay, so if you want to try that, go ahead, pause it and do that. And I'm going to work it out here. So it would look, if we said this was A, B, and C, we could go y prime equals A prime B, C plus A, B prime, C plus A, B, C prime. So that's my product rule that I'm going to follow here. And if I just want to leave it in a factored form, okay, so this one would be 1/2 times 5, so that 1/2 times 5 is 5/2. X to the power of negative 1/2 because we have to subtract. And then we have to multiply by B and C. So 3x squared minus x cubed times x plus 2x cubed. Okay. Plus, I'm going to just do one underneath the other. Okay. Okay, and then we've got A, 5x to the power of 1/2 times B. The derivative of B is 6x minus 3x squared times x plus 2x cubed for C. Okay, plus Okay, everything here, it's going to be the same here, 5x to the power of 1/2 times, the second one was 3x squared minus x cubed times the derivative of this last one, which would be 1 plus 6x squared. Okay, so there's our triple derivative one there. Okay, so there's 5 of those in the quiz, like, in each one of those, 2 marks each. We did one little example there. So question number 2. Okay, if we're doing question number 2, okay, so when we get into question number 2, I got a couple of chain rule things now. Okay, so this one is just a single chain rule question worth 3 marks. Using and that's only worth 3. It's just one chain rule. We're going to do some more chain rules with combinations later. Okay, so let's do a quick example of that. So it might be something like this. Let's say, y equals 3 root 9x minus x squared plus 2x cubed. So if we did that one as a chain rule, we could rewrite it first of all as 3 times 9x minus x squared plus 2x cubed to the power of 1/2. So we got to treat this like a variable here in our chain. So this would be like 3u to the power of 1/2. So if we do that and chain it together, 3 times the half, okay, and then this variable, take away 1 from that, okay, and then we got to do the derivative inside. 9 minus 2x plus 6x squared. Okay, we could do a little simplification there. So there's a simple chain rule example. Okay, leaving it, of course, leave your answer in factored form as well. Okay. Now, if I want it to be dirty in there, I might throw brackets around this and raise it to a power so that you have to use fraction exponents and stuff like that. But it's going to be something like that. And indeed, it does have a root in it. Okay. So question number 3 then. See where we are in time here. 13 minutes, good. Lots of time. Question number 3 is a combination rule. Okay, so combination rule. Using a combination of the chain rule with a power or quotient rule. Or sorry, with a, not power, with a product or quotient rule. And this is 4 points. Forming a derivative with a combination of a chain rule with a product or quotient rule. Okay, that's what you would have there. Okay, so if we were to do one kind of like that, we'll do a simple one here. If we had y equals x squared minus 8 times x cubed plus 5 to the power of 3. Okay, we could do that one there. It's got two chains in there that we can do. So if we consider the first part and rewrite it as x squared minus 8 power of 1/2 times x cubed plus 5 to the power of 3. Okay, you can try that if you like, and then I'll pause and work it out if you like, if you want, and if you don't want, I'm going to do it right away here. Okay, so if I'm going to do that one, and if I say this is f, then f prime would be 1/2 of that whole expression, power of negative 1/2 times the derivative of what's inside. Okay, so if we reduce that a little bit, that's 2 and 1/2 is 1, so just x. Okay, so that's that part. Now if I do g, being the second part, okay, g prime is going to be 3 times that whole expression squared times the derivative of what's inside. So this would be 9x squared times all this. Okay, so now I've got it all set up, and I can just do my product rule. Fg prime. So if I do Fg prime first, so F times G prime plus G F prime. So F prime was there. What do we got there? X times x squared minus 8 to the power of negative 1. Okay, and then there's our factored form of a chain combination rule, that one using the product rule and the chain rule. Okay, coming into the fourth one. Okay. There's only 5 questions, by the way, if you're wondering. Okay, fourth one, question number 4. Okay, this is a 4-mark implicit differentiation. Use implicit derivative skills. Okay, so something like this. X cubed plus 2x squared y cubed minus 8 equals 0. Okay, so obviously we got to do the product rule there. So if you're doing the product rule, f equals 2x squared. So f prime equals 4x. Okay, and g equals y cubed. So g prime equals 3y squared y prime. Okay, so then if we do f g prime plus f prime g, we're going to get 2x squared times 3y squared y prime plus f prime being 4x times g, which is y cubed. Okay, we can reduce that front part there to be 6x squared y prime plus 4xy cubed. Okay, so now we can do the derivative using implicit differentiation. So this one's just 3x squared. This one we figured out down here, so we write it out. Okay, derivative of 8 is 0, derivative of 0 is 0. Okay, so we got to leave this on this side and then bring everything over to the other side. So leave the 6x squared y prime, and then bring on the other side negative 3x squared minus 4x y cubed. Divide up both sides by this value, negative 3x squared minus 4x y cubed all over 6x squared y squared. Okay, we could reduce an x out of each because there's an x there, an x there, an x there. So, and we can't reduce 3, 4, and 6. So we'll leave that, reducing an x out of each, 3x minus 4y cubed all over 6xy squared. That's our implicit derivative. Okay, and that's our second last question. Okay, let's see where we are on time here. Okay, 22 minutes, good. I'm going to get this done in under 30 minutes. That's good. Okay, so our last question, question number 5, is finding the slope of a tangent line at a certain point. Okay, I'm going to do that on the next page here. So question number 5. Given a curve, find the equation of the tangent line. At a point. The one I got on the exam, I forgot a y on. I'm looking at it right now. I better fix that. I will. Okay, so this is worth 4, 8, 12. Yeah, 4, so it's out of 25. That's what I'll do. Okay, so 4 points. Okay, so something that you might use any of the derivative rules. You might have a quotient rule, power rule, product rule, chain rule, whatever. It can be any of those rules in this particular question, but let's say it's something like this. Find the equation of the tangent line. There we go. Find the equation of the tangent line. At x equal 1 for the curve y equals, let's make it a cubic equation. X cubed minus 7x squared plus 8x minus 5. I have no idea what this is going to turn out to be, but whatever. Hey, let's do a weird one. I'm going to throw this pi. I'm going to throw, instead of -5 in there, I'm going to throw a pi in there. Okay, I chucked a pi on the test, so just to show you how pi works. Not necessarily in that question, but pi. Okay, so we've got to take the derivative first to get the slope. So this is 3x squared minus 14x. I don't know why I'm putting in brackets there. Minus 14x plus 8. Okay, derivative of pi is 0 because pi is a constant. Pi is 3.14. It's just a number. So don't get thrown off. If I say pi x, then you have to leave pi in front when you take the derivative. We'll be using pi a lot in our next unit and the unit 1 after that. Okay, so there's our derivative. So then we got to plug in 1 to see what the slope is at 1. So 3 times 1 squared minus 14 times 1 plus 8. Okay, so we got 3 times 1 squared, which is 3, minus 14 plus 8. So if we do all the math there, 3 minus 14 is negative 11. We have negative 3 for slope. Okay, so it's going that way, tangent line. Okay, and then we have to figure out what the point is going to be. So, I see pi is going to be dirty in there. Let's not put pi in there. Let's go back to 5 because I'm trying to do too many things at once. Sorry, guys. If I put 5 in there, then we're going to end up with a number with 3.14 decimals in it. We don't want that. Okay, so now we want to do is find the equation of the line. So we have to find the point on the line. So find the point on the line. Or in this case, it's on a curve. It's not on a line. It's on a cubic curve. So 1 cubed minus 7 times 1 squared plus 8 times 1. That's why I took away the pi there, minus 5. Okay, sorry about that, guys, equals 1. So this is, or equals y. 1 minus 7 plus 8 minus 5. Okay. So this would be equals y, sorry. Okay, so then we would get minus 6 plus 2 minus 3. Oh, minus 3 equals y. So our slope is minus 3 and our point is 1 and negative 3. Okay, so now that we have a slope of negative 3 and a point of 1, negative 3, we can find the equation of the tangent line. Okay, so if we remember, equation of the tangent line is fairly simple. If you use the slope-intercept form of y1 over y2 equals x1 over x2 equals the slope m, okay? Or you can write it out like this. Okay, so y1 minus y over x1 minus x equals slope. And if you rearrange that so that you're cross-multiplying, you can write it like y1 minus y equals m times x1 minus x. And the ones represent this point. Slope represents the negative 3. Okay, so let's go ahead and plug it in. Okay, so that point of y is negative 3 minus y equals negative 3 for slope. And x is 1 minus x. So there's our equation to simplify. Negative 3 minus y equals negative 3 plus 3x. Okay, so we kind of get our slope of the line. It's going to end up being, well, the 3's are going to cancel out. Bring the y over here. We're going to get 3x plus y equals 0. If we bring everything over to this side, add y, add 3. Okay, that's the slope of the tangent line. And that's the quiz. Okay, so that's pretty much the quiz, and I'll send that out to your supervising teachers for you guys to write. Okay, and that's about 30 minutes. I don't want to go much farther than that. And we will get into the fourth unit next day.